Hello everyone. In this recording I will talk about the work and the energy of a particle. So as we said in the first lecture, the Newton's second law is the basis for dynamics. So in the first case we talked about kinematics, and then we talked about the force acting on the body, and then we call it as a kinetics. And then today we will talk about the work and then energy. Okay, but if you just go, what is the basis for all of these? The basis is the Newton's second law. If you understand the Newton's second law, if you get familiar with the terms, the acceleration, the mass, the forces acting on the body, the net force, the direction of the forces, and the vector terms. And if you get the basic understanding of the Newton's second law, then you will understand the dynamics very well, because all of them, it's all built on the Newton's second law. So let's firstly see how do we get the work and then energy principle. And Newton's second law says that the forces acting on a body, let me just show this way actually. The forces acting on a body will create the acceleration. Or you can say the net force is equal to acceleration. Let me write in words that the forces and then instead of these forces you can also say that net force, okay, let me do it this way, yeah. Net force. So net force creates acceleration. And then what does the work and the energy principle tells us? The work and the energy principle tells us that let me put it this way. The work net, actually let's put it this way. The work is equal to kinetic energy change, or I will put it this way, the work net is equal to the kinetic energy change. Okay, so works actually acting on the body create the kinetic energy change. And instead of the works, different kinds of works, we can just say that the net work. And then so you can see the similarity. The Newton's second law says that the forces create acceleration. The work and then energy principle says that the work create the kinetic energy change. It is just like one level up. So it was the force, now it became the kinetic energy. And then, the acceleration, now it is kinetic energy. It was the force, now it is the work acting on the body. Okay, this is the basic principle behind the work and then energy principle. But let me just show a little bit derivation on how do we get it. I will not show the complete derivation because it will take a good amount of time. I will just only show how do we move from MA to kinetic energy. So let me add a small derivation. Then the question is that how do we move from the MA to kinetic energy change? Okay, this is the question that we need to answer. And then let's start one by one. The first thing is that the work is equal to the force into distance. Okay, but then more formal way is that, more official, more scientific way is that then the work is the force with the dot product with the let me put it this way, displacement. Okay, and then this also a vector. And then the most formal is that then the work is the force dot with ds, and then ds is infinitesimal displacement. So instead of going with the, so you can see the step by step that we move to the, we increase the formality. The work is the force into distance, but then we go with the dot product. So let me add this one here, that it is dot product. Then dot product says that the work is the force into the displacement, and then the last one says that the work is the dot product with displacement, but with a infinitesimal displacement. So why do we go with this case? Let me just first explain it, and then we will move one more step. So then let me add it this here, so that y then f into ds. So y ds. Okay. So say that this is the particle that we have. And then the particle moves this way. This is particle. Okay, and then you can see you may have a force, something like this one here. You may have a force, something like this one here. You may have a force, something like this one here. Okay, you see the magnitude and then the direction of force changes. So along the path. So you can see as it moves along the path, the magnitude and direction of the force changes. So what's the solution? Solution is take a very small segment. Let's say the part of the path. Here we take the ds. Okay, then such that, let me remove the vector sign here, that such that the force is constant. Okay, it is like, let me just show it here as a chart. So I have a chart of the force and then the displacement s. So this one is the displacement s. Okay, and then I may have a different force. Say that the force is something like this one. Yeah. Okay, this is the force, and then if I take a small displacement on this force, so if I take a, and this one is ds, and this force, and then this part is almost constant. Then So why do we do that? Because this is like the calculus, we are trying to get more, we are trying to see the big picture starting from the pieces of the puzzle, You are just trying to see the whole puzzle, but you have to start from the pieces. Okay, that's the issue. Okay, that is what we mean here. So we have it, and then we have the f into ds, and then now comes the last one, and then I will move on to the derivation. Okay, so then if the f and then ds, so they are in same direction, then the work will be positive. Okay, and then vice versa. So let me just give you one example here, so that otherwise then the work will be 0. Let me give you one example. Say that this is the force and this is the ds, and then the work will be positive. Okay, and this is the force, and then this is the ds. Again, the work is positive, and this is the force, and this is the ds. Then work is negative, and then you may have a force, and then you may have a ds, and then this is the work is 0, less than 0. Okay, this is how it works, and this is how we get it. So in simple terms we can say that, so direction of motion and then applied force, direction of motion, actually let me add it here, direction of applied force, okay, if they are in the same direction, so let me, this is just this direction of motion and direction of applied force, if they are in the same direction we have the work greater than 0, otherwise the work is less than 0. And then with this one here I will stop it and then continue the next recording.